thanks so much for the question. First, I'm sorry if it's really bright. I've just got the sun right on me, but yeah, I think I can help with this one. I know it's a HSC Maths Advanced question, which isn't necessarily the syllabus that I specialize in, isn't something that I've covered, but I think I can help you with this question nonetheless. So I've just gone ahead and drawn our sine curve for the domain we're interested in, which is between 0 and pi inclusive. What that means for sine is that it's going to start at 0, peak at 90 degrees or pi on 2 radians, then go back to 0, but we're not going to get any negative solutions. So what we're looking at is only a half period here. Now, what we can do with this graph that we've drawn, and how I interpret this question, which might not be, I guess, the best approach in light of what the HSC syllabus asks for, but how I would see it is like, look, you've got, this is your first curve here, and we just want to find, okay, well, where does this intersect with the other curve you're looking at? And all of these are just going to be lines. So the first one is just going to be a straight line with a gradient of a half and an intercept at 0. So it's going to be here, and then it's going to go up in increments of a half. What's kind of difficult to figure out here is, well, what is, oh, sorry, something I missed I should have drawn in is that this reaches 1. So that's the maximum there is 1. That'll be important. So what we could figure out is we could try and, okay, if we've got a straight line with form y equals half x plus 0, we know it's going to connect in at 0, first of all, but more than that, we need to figure out, okay, is it going to connect anywhere else, or is that line too steep? And so we can evaluate that by maybe subbing in pi on 2 here. All right, so we substituted in our point here, pi on 2, that's our x value, and we're trying to find, look, at this value for the actual, so we know it's a straight line, but when it gets to this point at pi on 2, is it above the curve or is it below the curve? And based on the fact that the y value would be pi on 4, which is approximately 0.7-ish, it's going to be below, like maybe there somewhere. Okay, and just to evaluate and confirm that this line is then going to pass above what we've got at the moment, if we sub in pi, we get y equals pi on 2. That's about 1.57. So by the time it reaches this point, we're well above the curve. And with all of that information in mind, we can then suggest that, look, our curve is going, and I'll draw it in a different color. I'll make it, let's go purple. This is a straight line that passes through the origin, comes up, will intersect at some point there, and then pass on through. And so if the aim of the question is just to find the number of solutions, so we just want to quantify how many solutions, depends again on the interpretation of this. For me, it's inclusive of 0, and this graph is also inclusive of 0. So I would actually consider 0, 0 to be an intersection point. I'd then also consider this point up here to be an intersection point. And you don't need to know what it is, you just need to define it. So for this first one, I would say that is 2 intersection points. The second one here is a little bit different in that it starts below the origin. So we're going to get a graph that looks more like that. And so the first glance take is like, yeah, we'll get an intersection point. And that's probably correct, but we need to check it. So the two things we need to make sure it's below the curve there, but above the curve there. So if we sub that in, we've got half times pi on 2 minus 1 that's going to give us pi on 4, sorry, pi on 4 minus 1, which was, if you remember over here, pi on 4 is about 0.78. We take 1 away from that, we're actually looking at a negative number. And so I've even drawn this wrong here. This would be all the way underneath the curve. But what that shows us is, yes, it's above the curve line. It's the sine of x is actually 1 there. All right, so now we just need to see, okay, does it resolve to be above 0 after it passes pi? And to do that, 1/2 times pi minus 1. That's going to give us approximately 1.57, and we know that from above. Take away 1, yes, we're above 0, we're at 1.57. So I've drawn this even slightly above where it should be. In actuality, this second line is really going to be more like that. That's the kind of shape we're looking at there. And so there's only going to be one intercept, and it's going to be just before pi. All right, and finally now we're looking at this function, and it seems to take a little bit of a different flavor because we've got an x there as well. But this is kind of a red herring. We just need to simplify it. So we've got y equals x on 2 minus x. We just need to get this to a common factor. So we can say that that's the same as x on 2 minus 2x over 2. 1x minus 2x is just going to be negative x over 2. So what we're looking at is actually similar to graph A, except on this occasion, the direction of the graph is reversed. And immediately, I think we can rule out the fact that there's going to be any additional intercept points. Because if we draw that line, we know it's got a c value of 0, so it's going to start at the origin. But it's going to go down. And there's no way that it's going to have any other intercept points except at 0, 0. So again, if 0, 0 is considered an intercept point within the syllabus of this work that you're doing, I feel like that would make sense. And so I would say there's only 1 there, and it's at 0, 0. Okay, hope that helps. Please let me know in the comments if I've made any mistakes, actually. This is not for my syllabus, so I'm not sure if I'm taking the right approach here. But this is how I would tackle these questions. And hopefully that graphical understanding makes a little bit of sense for you there. Thanks so much.